All right, my friends, let's take a look. Getting started with graphing, I personally like to isolate y in both situations, and that kind of serves two purposes. When you get to doing it by substitution, it's kind of nice that you would have done that already. So for the first equation, y is equal to the opposite of x squared plus 2. So graphing that function would just be a normal x squared graph and then shift it up 2. So vertex at 0, 2, and then out 1, down 1, and then resetting at the vertex out 2, down 4, just kind of thinking about squaring 2 or negative 2. And so now if we ever need more accuracy, we could always add that in, you know, go out 3, down 9 or something like that. So no big deal. Okay. And then for the second equation, I'll just isolate y on that one. And so we would just have set of all points where your x and y coordinates are the same. So notice for these, if you're doing them graphically, you probably want to do a little more accuracy than normal. Oops. Just as I say that, I draw a really ugly line graph. Anyway, so according to the picture, it looks like we should have points that satisfy both equations, one at 1, 1, and then the second point here at negative 2, negative 2. Then you could always check and see if that's right by plugging, 1 and negative 2 into both equations and seeing if it makes them true. That's kind of nice about problems like this. You can always check and make sure you're right. Anyway, so now let's show how to do this problem by substitution. Typically, if you do a problem by substitution, you can springboard off of the work we've got here if you want. Typically, if I was to do this by substitution, I would just solve for one of the variables. It doesn't matter which one. And in the easier equation, so for me, that would have been line 2. And then you could take, the fact that y is equal to x, and then you could substitute it in, for y in the first equation. And the point is that you're trying to get down from 2 equations with 2 variables down to 1 equation with 1 variable. So anyway, so if you did that substitution, then that first row right here would then say x squared plus, and then x instead of the y there, and then equals 2. Then from there, you just have to remember if you have more than one x term to get 0 on one side. So in this case, that would mean subtracting that 2 over. And then let's just use the 0 product property. So we'll factor 2 and 1, boom, boom. And then the 0 product property, if you set each of the factors equal to 0, you'd get your 2 solutions. So x could equal negative 2, or x could equal negative 1. Or sorry, positive 1, that is. Anyway, and then from there, you could just take these one at a time and then back substitute into either equation, row 1 or row 2. I personally like row 2 because it's so much simpler. And since it doesn't matter, I might as well just use row 2. So if x is negative 2, if you kind of think about back substituting that into that relationship, then that would mean that y is also negative 2. And then some notation that I kind of like that you could use here would be y when x is negative 2 is negative 2. And then similarly, if you take x equals 1 and put that into either equation, I like row 2 because it's simpler, then y when x is 1 would be 1. Anyway, so when you're done, let's always write our answers in ordered pair form. So you would just take, this information right here, and that would turn into the point negative 2, negative 2. And then you could take this information right here and turn that into the point 1. There we go. So these would be your solutions. All right, my friends, hopefully this makes sense. I'm guessing this is a review, but if it's not, then hopefully it's making sense. All right, example 1, let's have you solve the system of equations. X squared plus y squared equals 4, and x minus 2y equals 0. For part A, let's have you do it by graphing, and then for part B, by substitution.